A while back, we talked about there being 5 rules for absolute values, and I gave you 3 of those rules in class. Today, we're going to cover the other 2 rules here as part of example 10 on page 297 in section 4.4. Rule number 4 says that if you have the absolute value of A less than or equal to A, and it doesn't really matter if the equals is there, the rule doesn't change. The only thing that would change is you wouldn't have the equals here as well either. So your book sort of breaks it up into 4 rules. It's really just 2 rules. I think it's easier to keep it straight that way. But when you have the absolute value that's less than or equal to A, then what happens is it becomes the stuff inside of the absolute value, the U in this case, in the middle, and the values of A and negative A on either sides of that U. So it becomes a 3-part inequality. If the absolute value of U is greater than or equal to A, and again, the equals is whether it's a part of it or not doesn't change the rule, it just changes the fact that it's part of the end of this. So if the absolute value of U is greater than or equal to A, then you have 2 separate things to solve. You have U greater than or equal to A, or U less than or equal to negative A. All right, remember when there's a negative involved, we end up switching the inequality sign a lot of times if we multiply or divide by a negative. So that's what helps me keep it straight, is if I have a separate thing and I put this negative for A in, then that means I've got to switch that inequality from what I saw before. So 2 things to solve here depending on how the rules are given. So let's go ahead and make these a little bit smaller so we can keep them on the page. Part A has the absolute value of 2x minus 3 less than or equal to 5. All right, so this is a perfect representation of rule number 4 here that says the absolute value is less than or equal to another value. Now, just like before, in order to use the rules, it has to look like the rules. In other words, it has to have an absolute value by itself on the left-hand side and some sort of positive number or 0 on the right-hand side. If it's a negative number on the right-hand side, it also has an answer called the null set because this isn't possible. All right, so once we have this in place, we can then use the rule here. It says the U. So whatever's in the middle here, whatever's in the absolute value is in the middle of this solving here. So 2x minus 3 is going to be in the middle. Our symbol stays the same as written twice. A positive 5 goes here and a negative 5 goes here. And then we solve. So our first step is to add 3 to everything. So add 3 to the middle and to the right and to the left. Okay, so we have negative 5 plus 3. That's going to be negative 2. We've got our negative 3 and positive 3, which means just 2x in the middle. And 5 and 3 makes 8. Then we're going to divide everything by 2 because we want just 1x in the middle, not 2x. And that's going to give us a negative 1 there and a positive 1x here. And 8 divided by 2 is 4. And so x is between negative 1 and 4, and that's a great answer. It's not interval notation answer. We do want the interval notation. Interval notation says because we have the equals, but we're going to have squares. So a square on the left, negative 1, comma, 4 on the right, and a square to finish that one off. And so the answer is somewhere between negative 1 and 4, counting negative 1 and 4. Again, with an inequality involved here, we're going to see an infinite number of answers, and there's an infinite number of answers on this scale. Part B, we have the absolute value of 3x plus 4 minus 5 greater than 0. So it certainly implies it is going to be looking like rule number 5, as in greater than 0. However, it doesn't look like the rule. We have an absolute value, yes, but we have something next to the absolute value. We need this 5 to be on the other side. And so let's rewrite this as 3x plus 4 in the absolute value greater than 5. All right, now we're ready to rock and roll here. We have our absolute value. We've got a number. We can totally do this. Okay, so the rule says absolute value, or what's in the absolute value by itself, is in 3x plus 4. And our symbol stays the same, greater than 5. That's going to be one thing we're going to solve. And then the other thing is 3x plus 4. Again, what's in the absolute value didn't change, but our inequality symbol does. And the value next to that inequality symbol also changes. So we change the inequality symbol. We make this a negative 5. Okay, in both instances, the first thing we're going to do is move the 4 over. So this is going to have 3x greater than 5 minus 4. This is going to have 3x less than negative 5 minus 4. This one's going to show us that 3x is greater than 1. This one's going to show us that 3x is less than negative 9. Both times we're going to divide by 3. It looks like here x is greater than 1/3. Dividing by 3 here. Looks like x is less than negative 3. So 2 answers, right? Greater than 1/3 and less than negative 3. Again, we want to use interval notation to tell us what the answer for this one is. Greater than 1/3 says that it goes from 1/3 to positive infinity. There's no equal sign here, so both of these are going to be rounded. Less than negative 3 says the answer is going to go from negative infinity to negative 3. Again, rounded brackets on that, and a u between them. And so there's our answer there. It's a little crammed in there. I apologize for that. Let's go ahead and put a square around that so we realize that that is indeed the answer that we found. The answer to part A was the interval notation of -1 to 4 with square brackets. The answer to part B doesn't have square brackets because it didn't have the equal sign. And it has more of a complex answer because we have the u joining 2 different areas here because it was greater than 1/3 and less than negative 3.